So electricity. So this is the next lesson of the syllabus. So it's actually next unit of the syllabus. So it's a very big unit and also a very important unit, which will be again very useful, especially in the higher classes, and also very important lesson both from the board examination point of view and also from the understanding point of view and also from the daily life, and even more important from the daily life applications point of view. So this big unit electricity consists of different small lessons. It's almost about 5 to 6 different small lessons. So first lesson is static electricity. Now, what is the meaning of electricity and static electricity? So electricity, one meaning is it's a branch of physics. It's one branch of physics, has many different branches. Optics, that's related to light and wave motion or sound, mechanics, heat, and thermodynamics, like the different branches it has. So electricity, one simple meaning is it's a branch of physics. Now, what does it deal with, and what is the other meaning of electricity? Now the second meaning of electricity is it simply means electric charge. Electric charge. So the first meaning of physics is first meaning of electricity is it's a branch of physics. What does it deal with means it simply deals with electric charges. So what is electric charge? So electric charge, its regular symbol is Q. Already we have seen the meaning of electric charge. So especially in the some 2 years back in the 10th class syllabus. So what is electric charge? Electric charge is nothing but that property which can be observed on certain objects. For example, a simple situation, you take a comb. So I'm just taking a comb here. Just see here, it's a comb I'm taking. Now this is a comb. So a regular comb is usually made up of plastic. So when this comb is rubbed with a piece of cloth, it's just rubbed with a piece of cloth. Immediately, some charge, some property is developed on the electric comb. Now this property, once it is developed on the electric comb, it makes the electric comb attract bits of other substances like bits of paper. So these bits of paper will be just immediately pulled towards the electric comb, will be just attracted by the electric comb. But not just bits of paper, even bits of cloth, bits of say straw, or bits of wood, small pieces of wood. Everything will get attracted towards this electric comb once this property is established. So how this property is formed on the comb, or not just a comb, even a plastic scale, a plastic ruler, or any plastic object. When it is rubbed with a piece of cloth, again the same behavior is actually observed. So once the comb is actually, I'll just change the diagram a little. So just observe here. So I did not change much. So only the bit of cloth actually I removed it a little further away from the comb. So when the cloth is actually rubbed against the comb, plastic comb, immediately the plastic comb is attracting bits of paper or bits of straw, etc. towards it. So why this is happening? Because some property is actually formed on the comb. It's actually shown as a plus sign here. So this property itself that is formed on the comb, which makes the comb attract the bits of straw or bits of paper. Otherwise, if this property is not formed on the comb, we know that a comb behaves just like a normal, like in normal situation. It will not be able to attract other substances. But once this property is formed, how this property is getting formed? Just by rubbing it with another substance like a piece of cloth. Then this special property is formed. This special property itself is called as electric charge. So not only attraction, sometimes this comb can even repel other substances also in certain situations. So either it can attract other substances or sometimes it can even repel. Repel means push it, push it. Attraction means the bits of paper are actually pulled towards the comb. Repelled means they are pushed away from the comb. Once some other substance is brought near it, it just gets pushed away from the comb. But that will be only sometimes it will be happening. But mostly, very easily this attraction property can be observed in sometimes, in some situations, even repulsion also can be observed. But why this attraction or repulsion is taking place? Because of this property, special property formed on this. This special property itself is called as electric charge, or simply it's called as charge. It's also simply called as charge. So electric charge or charge is that property established on an object which makes the object attract or even repel other substances. That property itself is called as electric charge. Now, very important thing about electric charge is it is found that every substance, not just comb, even say glass, not just glass, any substance, whatever substance that is visible around us, if it is rubbed by any other substance, not just a piece of cloth, even a piece of leather or any other substance, every substance when it is rubbed by any other substance, always this property is established. But in some situations like comb, it can be easily observed. But in all most of the other situations, it is very difficult to observe this. But it is proved that experimentally, always this will be happening whenever any substance. Always, I said many times, when you're observing, so when you're listening to the explanation, compulsorily observe the cursor. So whatever I'm explaining, I'm just showing with the cursor. I'm pointing out with the cursor. So it'll be easy to understand if you are just looking at the same diagram which actually I'm explaining. I'm just pointing out with the cursor. So whenever any substance, not just a comb, any substance when rubbed by any other substance, always electric charge is found on the substance. Not only on the substance which is getting rubbed, even the substance which is used for rubbing. This is called as rubbed substance. This is called as rubber. So cloth is called as rubber. So even this rubber, the substance which is used for rubbing, like that, it's completely called as rubber. Even this rubber also gets this property developed on it. So electric charge is that property which when established on an object simply by simple process like rubbing makes the object attract or repel other substances. This property itself is called as electric charge. So that's the simple meaning of electric charge or simply charge. So another word for this electric charge is it's also called as electricity. So electricity also means simply electric charge or simply charge. And the branch of physics which deals with such electric charges or this electricity, it's also called as simply, in short, it's called as electricity. Thus electricity has two meanings. One is it simply denotes electric charge, and the other is the branch of physics dealing with electric charges. Now electricity has many branches, again small sub branches. One is static electricity, next current electricity, next magnetism is also taken as a branch of electricity. A very very powerful branch of electricity is magnetism. So next electromagnetism, next electromagnetic induction. Now these are the main branches of electricity. And from electromagnetic induction, there are other small branches, just extension of these branches, especially last branch, electromagnetic induction. Extension is, it's called alternating current circuits. And then finally, electromagnetic waves. But last two branches are usually mixed with the fifth branch of electricity, that is electromagnetic induction. Just check the branches once again: static electricity, current electricity, magnetism, next electromagnetism, next electromagnetic induction. So electromagnetic induction, that's two small, very small subtopics are alternating current circuits and then electromagnetic waves. But many textbooks actually combine both the AC circuits, alternating current circuits and electromagnetic waves as included in electromagnetic induction. So this way roughly electricity is divided. Now the most important branch now is static electricity. So from the name itself, what is static electricity? Static means rest, we know. So it mainly deals with electric charges at rest, the properties and behavior of electric charges at rest. So the name is very simple. So now again coming back to electric charge, the meaning is or definition is very simple. So when electric charge is formed on the substance, it makes the substance like foam attract other substances. Now it is found that it is always experimentally proved that both the rubbed substance and the substance used for rubbing, that is a rubber, both of them are getting charged. In what way? Uh, what is the similarity or difference between these two charges formed on the rubber and the rubber? It is always found that, or experimentally, it is proved that there are two different types of electric charges in nature. So first type of electric charge is called as a positive charge, and the second type of electric charge is called as negative charge. So it is found that there are only two types of charges possible in nature. One is positive charge and the other is negative charge. So it is found that whenever electricity or electric charge is formed by friction, friction means rubbing here. One substance is rubbed against other substance means friction is present between. So it's called as frictional charging or frictional electrification. So in frictional electrification, always it is found that the rubbed and the rubber, so this is the rubbed substance comb, it's developing say positive charge, and the rubber actually develops negative charge. And this charge formed on the substance actually can be measured exactly. How it is measured? It is simply measured in terms of the force experienced by the substance which is attracted by the charged body. So here the bit of paper is actually attracted by the charged comb. So it is found that if more charge is found, supposing it's rubbed only once, small charge, small amount of charge is found. Two times it is rubbed means more amount of charge will be found. So when more charge is found, it is found that the force also will become, force of attraction also will become more. So that's the simple way by which how much charge is formed on the comb can be roughly known. So by this technique, by measuring this force, how force is measured? Force always in any situation is measured by Newton's second law, the most powerful law. It is said to be the most powerful law in nature, because from this law many other laws are actually derived. This has the widest applications in nature compared to any other law. So powerful is the Newton's second law. The basic use of Newton's second law is what? It is used to measure force or analyze force in every kind of situation. So using Newton's second law, force can be measured. So this force, once it is measured, in terms of this force, charge also can be indirectly measured. More force means more charge. That way, charge is usually measured, formed on the substance in terms by measuring the force. So based on this, charge can be measured and charge proper units have been defined. In SI system, the SI units of charge, or in SI system, charge is measured in a simple by means of a simple unit. It's called as Coulomb. Coulomb is the name of a scientist who actually invented a law, who gave a certain law which actually gives the force between two charged objects. Two charged objects actually they'll be applying forces on each other. So what type of forces? Many times you have learned these forces. So two like charges, positive and positive charge will repel, or negative and negative charge will repel. Or two unlike charges, positive and negative, or a negative and a positive charge, they'll attract each other. So this force present between two charges. Here always whenever we are considering charges in this lesson, we just assume that both the charges are at rest. When charges are in motion, again different kind of force also will be coming into action, but that's a different situation. That will be coming in magnetism. That will be coming in magnetism when charges are in motion. So now we are dealing with only charges at rest. So magnetism is actually part of electricity. Already just now we have seen. It's the third lesson or third branch of electricity, or third sub branch of electricity. First sub branch of electricity is static electricity. Next, current electricity. Current means something in motion. So from the name itself, it means that it deals with electricity or charges at in motion. Like that, magnetism. Magnetism is something related to a very special property of charges in motion. So that we'll be seeing later. It will be coming in syllabus clearly. Already have learnt all these things to some extent in the previous years. Here in more detail, in almost full detail, the topics will be actually coming here in this year. Okay, so the SI unit of charge using which the charge present on any object can be measured is Coulomb. So this Coulomb has been named after a scientist, Coulomb, by name Coulomb, who actually invented this very powerful law which actually measures force between two electric charges. So because the unit is actually named after scientist, any unit named after a scientist, the full name should be written with small letters. Just see the full name, Coulomb, Coulomb. So you can just see the spelling here more clearly in the print actually. So here I've written the same thing, Coulomb, Coulomb. So named after scientist, the full name of unit should be in small letter, but the symbol should be capital letter, just like Newton symbol, 5 newtons, 5 capital is written. But whenever unit name of scientist is written in full, it should be written with small letter. So always this is a very important rule to be followed while writing SI units. So that's about the SI units of electric charge. So the definition is also very simple. Now, two types of charges. How many types of charges are possible in nature? Experimentally, it is found that it is proved that only two types of or two different charges exist in nature. One is positive charge, one is negative charge. In an atom, also, you have learned many times, especially in chemistry and also last year or before last year physics, you have learned that atom consists of two types of positively charged particles. One is electrons, negatively charged particles. One is nucleus, which is actually positive charge mass present at the center of the atom. So this positive charge mass nucleus inside an atom at the center of the atom consists of positive charged particles called as protons. They carry equal and opposite charge as an electron. For example, electron charge is written as E. So electron charge is written as E. So it's a negatively charged particle. It's written as minus E. So proton charge will be what? Equal and opposite. Proton charge inside the nucleus is plus E. It's written. So these are two very important symbols related to charge of electron and charge of proton. Simply E stands for electron. So proton also has equal and opposite charge as electron. So it's written as plus E. Electron being negatively charged particle, it's written as minus E. So that these are two simple examples of the two types of charged particles, positive and negatively charged particles. Next, a very powerful law, the law of conservation of charge. Now, this is one of the most powerful laws. It's actually a fundamental law. So, in nature, it is found that everything can be explained with the help of three fundamental laws or three sets of fundamental laws. The first set of fundamental laws is the Newton's laws of motion. Second is conservation laws, conservation of mass, energy, and charge. So, this is the belong to the second set of fundamental laws. And third fundamental law is a single law, Einstein's principle of mass energy equivalence. So these are the three very powerful fundamental laws of nature. So there are three fundamental laws. So all these whatever things we are seeing, I'm just explaining this as general point. Three fundamental laws exist in nature. What are the three fundamental laws? One is Newton's laws. Next is conservation laws. Newton's laws, there are three Newton's laws we know. Second law, F is equal to ma is the most important law. And the third set of fundamental laws is, this is a very simple thing, but always useful. In almost every lesson, these three laws are actually used in one way or the other. And the third set of fundamental laws, it's a single law, it's the Einstein's principle. So Einstein's principle also you have learned in modern physics actually. In atomic physics, maybe one small portion of 10th class syllabus you have learned this one, Einstein's principle, mass energy equivalence principle. Just remember this. I'm just writing this in the rough column because again and again we'll be seeing them, so you must compulsory note this in the rough columns. I'm just mentioning it as rough. I did not take much space here because there's not much space here. I'm just mentioning it as rough. So what does the law of conservation of charge consist of? Now take a complete universe. Imagine that this is a closed enclosure is like the universe, or any closed enclosure also we can take a closed box. Supposing that from outside no charge is going inside, or from inside no charge is going outside, then the law simply states that. So statement is almost similar to law of conservation of mass and law of conservation of energy. Law of conservation of mass states that total mass is constant in a closed system. So conservation of energy also, total energy in a closed system is constant. So the same thing, conservation of charge also statement. Statement is very simple. The total charge in a closed system or total charge in the universe always remains constant, and charge can neither be created nor destroyed. Just like energy statement, you see, conservation of energy statement. Total energy in a closed system remains constant. Energy can neither be created nor destroyed. The same thing, charge also can neither be created nor destroyed. Total charge remains constant in a closed system or in the universe. Energy can be converted from one form to another form. Like that charge here, it can't be converted, but charge can be transferred from one object to the other object. Always this transfer will be occurring such that total charge in the system remains constant. So that's the simple statement of the law of conservation of energy. So statement is very simple. So later I'll give some time for writing the statements. Always the most powerful things in science and technology are the definitions. Definition of quantities or the definitions of the laws. Definition of the law means simply statement of the law. like Newton's second law statement, Newton's first law statement, here conservation law statement, like that. These are said to be the most powerful things in the universe, most powerful things in science and technology. Anything, everything in the universe can be understood just by applying the scientific definitions. Scientific definitions like definition of electric charge, or definition of force, or definition of any quantity, or the statements of laws. With the help of these two things, scientific definitions and fundamental laws, everything, anything and everything in the universe, it is said that can be understood very easily, very clearly. So that's the power of definitions and laws, scientific definitions and fundamental laws in science and technology, or science and engineering. So these are the simple things. So statement of the law is very simple, nowhere any complication is there. Now, so whatever things we are seeing here are simple, nowhere any complication is there. Now coming to the main law of the syllabus. So whatever topics we have seen, this is a very simple topic. Just see electricity, electric charge definition. It is very simple, but it doesn't carry any marks. So whatever any topic carries marks, what is the importance? So this is very important, but it can't be given for any marks. So I'm not putting any marks here. So units, SI unit name, since 10th class, almost 2 years back also you have learned this. So definition of Coulomb actually will be coming here in this lesson only. In the next topic, it will be coming definition of Coulomb, how Coulomb is defined. So next, law of conservation of charge. This is also, it doesn't carry any marks, but it's one of the most powerful laws of the universe. So because it doesn't really belong to the syllabus, so the actual syllabus, first topic belonging to the syllabus is the Coulomb's inverse square law of electricity. So this is a very important topic. It carries marks ranging from 4 marks to 2 marks. So 4 marks, full 4 marks, it's never given. So mostly it's given for, so always 4 marks always doesn't mean full marks exactly. So it can be plus or minus 1. So 5 marks also it will never be given because it's not an essay topic. 5 marks means it should be an essay topic. So mostly it's given for 3 marks and 2 marks. 2 marks also usually it will not be given. Only if a statement is asked, then 2 marks it will be carrying. Just a statement is asked like this. Then it will be carrying 2 marks. But usually just statement will not be asked. Its explanation also will be asked. So that way it will be carrying 3 marks. Then where is the 3 marks question given? 3 marks question is given as a part of a essay question, or a part of a essay question. Some boards carry essay questions carry 8 marks also, but most of the boards carry around 5 to 6 marks. So as a part of an essay question, for example, 8 marks essay question, 3 marks Coulomb's inverse square law can carry. Remaining 5 marks, another big essay question can be given. That way it acts as a short answer question. And for 2 marks means it also acts as a very short answer question also. And very important is, from this Coulomb's inverse square law, most powerful laws in electricity have been derived. Very powerful laws, not just in electricity. They are almost like general laws which are actually applicable in almost every branch of physics and also every branch of engineering. That's the importance of Coulomb's inverse square law when it is applied in daily life, or when it is applied in science and technology, or science and engineering. Now, what does Coulomb's inverse square law state?